You know, Ben, with all that 4K video you're producing, you're gonna quickly run out of room on that 4 terabyte SSD that you snagged before the Rampocalypse.
Yeah, I suppose, but I don't really have any place to offload it to. I have Google Cloud and a portable hard drive that's probably going to shit the bed any day now with all of Bangray Digital on it. Plus, who wants to carry around a portable hard drive?
If only there were some sort of solution for mass storage that you could access from anywhere. Perhaps some sort of, like, I don't know, network attached storage.
Most of what I've made previously is bullshit with a side of useless. Great creations and there's more to come, but it's probably a good time to dip my toes into something that actually personally benefits me with a main course of actual industry-leading technology. Now don't get me wrong, I've made a server before. So where did this idea to make a network-attached storage, or NAS, come up? Well, the idea has been appealing to me for quite some time now, and I've always wanted to kind of make one, but more so after I spent over $100 on just a year of 2 terabytes of Google's cloud storage, in which at that point I considered that it might be time to start investing in my own personal cloud. As per usual, I did not end up doing my research before actually buying anything. So I ended up getting two 3.5-inch 4 terabyte 12 gigabit per second SAS hard drives for about $108. As well as a SATA hat for the Raspberry Pi, because my original idea was to use the Raspberry Pi to make network attached storage so it would be small, but like I said, I didn't do my research and I ended up with SAS storages when I had a SATA Raspberry Pi hat. So that's when I learned about SAS versus SATA. And I thought, you know, maybe you could just buy a SAS to SATA adapter and move on with your day, you know? Something like a USB-C to USB-A type deal. Not quite. You see, SATA, or Serial Advanced Technology Attachment, was originally created in the 2000s to replace PATA, Parallel Advanced Technology Attachment, originally created in 1980. SATA is pretty standard in most consumer electronics. You can find it on all SATA SSDs, as well as some 2.5 and 3.5-inch hard drives. Well, as you may remember, I ordered SAS hard drives. SAS stands for Serial Attached SCSI and was created in the mid-2000s following the creation of SATA. SAS, compared to SATA, is the preferred solution for industry. In a nutshell, SAS drives provide better capacity, read-write speeds, as well as being deployed with the intention to be up 24/7. Essentially, I ended up with the low-capacity version of the same hard drives you would find in modern data centers. So that means future Bangray Digital will have a SATA Raspberry Pi hat to do something with. So what is the solution to getting these SAS hard drives connected, you know, to a device? Well, that would be a PCIe RAID SAS controller. This device, at least the one I got, plugs into a PCIe by 8 lane, similar to a graphics card would. This enables a high-speed connection between the computer's storage and compute. That can be either the CPU or GPU, depending on your use case. Another thing about SAS hard drives is that they require a fair bit of power, much more compared to their SATA counterparts. This meant I needed hardware that had both PCIe slots and a power supply. At this point, this is where I looked at that old PC I got from Facebook Marketplace half a year ago with the original intention to make that Minecraft server, which I ended up using the HP ProDesk for, and low-key now just sits on my desk because the Minecraft phase comes and goes quicker than you think. From my understanding, all the Facebook Marketplace computer needed was a new motherboard and it would run great because the CPU pins were bent on the original motherboard. So let's look at eBay and find some motherboards to use. Let's first look at my notes here to see which socket I need. Oh, that's a number of a socket type that I had noted down, and I'm sure is the one that correlates to the computer that I needed a new motherboard with, right? So I ordered a motherboard with that same CPU socket, and oh no, that's the motherboard for the HP ProDesk. Okay, let's order the correct motherboard. Okay, so I get the correct motherboard with the correct CPU socket, I throw in the Core i7, and that should be that, right? get everything plugged in, and doesn't seem to be working. Maybe the CPU issue on the old motherboard was not only the pins, but also maybe the CPU. So I go back on eBay and order a Core i3 for like 10 bucks for what I think is the right motherboard socket, and nope, that one's for the HP ProDesk. God damn it. So I go on again and order another Core i3 for the correct socket this time. It finally gets here. I put it in the motherboard, get it plugged in, and in that moment I realized that the motherboard I got, and the cheap one, is probably supposed to work with the HP workstation it was meant to, you know, go with. So now I have two motherboards and two CPUs, 3 if you count the i7, and no working computer. I did return the two motherboards and get $45 back, but I felt that the environmental impact of returning two $10 Core i3s is not worth it. So what now? Since I'm not getting that marketplace computer working still, perhaps I purchase something that actually is guaranteed to work with a free return so I can't get scammed. And then from the perfect search query with free returns and free shipping for $150 came the Proleon ML30 Gen 9 Intel Xeon E3 1220 V5 3.0 GHz 12 gigabytes of DDR4 RAM, which was actually pretty cool. No HHDs and no operating system. So after a day of contemplation and being sent a 10% off deal and watching one single video on it, thank you IT Creations Inc., I made my $150 purchase, and a few days later it arrived. Now, I did also need an SSD for the operating system, so I did end up ordering a SATA 128GB SSD for $25 along with the computer. So the HP Proleant, however you wish to say it, got here and it was dusty as hell. And I've worked with a lot of dusty computers before, but nothing quite like this. Clearly it had been sitting on a shelf in a hardware somewhere for quite a while. So I got it cleaned up, looking a little nicer. I refreshed the CPU's thermal paste, found two computer power cables, plugged it into the dual hot swappable 460 watt power supply units, and booted the system. Lights were flashing green, so I knew everything was working as it should. Unfortunately, the system was only from 2016, which was only 10 years ago, let's not forget. So it only had a VGA cord, which meant I needed to go and order one in order to get the system to show up on my also old monitor, so I can see what exactly the computer is doing and get the system booted up. And that VGA cable did take its sweet time arriving. The main issue I ran into after I got the PC was that the hard drive bay was for 2.5-inch hard drives and not 3.5-inch hard drives, which meant I needed to somehow use the cavity to get the drives working. So I tried a few wacky configurations, including removing the back panel, which actually read the information for the SAS hard drive, put it on its side, plugged one of the drives in, both of them eventually, so that I could actually make sure they were working, because up to this point it had been about 2 weeks and I still wasn't sure if the hard drives I initially purchased even worked. And thankfully they did, but after a few configurations I decided to just, you know, throw out the backplane. I didn't actually, because that thing's worth like $80, and kind of just stack the drives on top of one of each other and call it a day. This meant that the computer was fully working, had a working SSD for the operating system, as well as two 4TB hard drives. So now it was time to figure out the software side of the server. So first off, I had to choose an operating system, and there are a number of systems out there. A few of them I looked at. The main two were Docker and TrueNAS. Now, while Docker seemed like a great system for setting up a network attached storage, it did seem more focused at being an operating system in which you could run programs like AI models or remote machines with more than an actual NAS. So that's when I decided to use TrueNAS, because its entire marketing was essentially scalable network attached storages for business and enterprise and all that good stuff. And so I went with TrueNAS. So I got the download, and from my past experience with Raspberry Pis, I thought you could just flash the image to the storage medium directly. Nope, that's not how actual computers work. I had to get it on a stick, a USB stick, plug it into the computer, get the VGA cable plugged in, get it all worked out. I ended up needing to meddle with the HPE interface because the setup wasn't really working at first, even after I managed to actually install TrueNAS 3 separate times. Something was going on where the RAID SAS controller wasn't properly being detected, or the drives weren't being detected. I don't really know what I did, but it got working in the end. After which, I got my IP address to the server, went on my laptop, connected the IP address into the web browser. It came up with TrueNAS, took a second, but it came up with TrueNAS, entered my login credentials, and I was in. Now, this whole ordeal did take over 2 hours, and I didn't even finish it the initial evening. I was trying to get it set up. I gave up, came back in the morning, changed one thing, I think, and it started working, which was frustrating, but whatever. But I digressed. I followed a few tutorials, figured out how to set up pools and users and groups. The system itself, it didn't work initially. I tried to connect to it via the network folder on my Windows laptop. It was saying there were some issues even though I put in the right credentials. I meddled with some other things, went through the tutorial again, and came back like a day or two later and something was working again, which is great. And this meant I had 4 terabytes of redundant mirrored storage that I could access anytime I was on my network. And this is lovely and all, but I did have an original goal with this project, and that was to replace Google Photos. So this is where the second piece of software comes in. Immich, a near one-to-one of Google Photos, accessible from either a web browser or the mobile app that you can find on iOS and Android. Immich has a load of tools to keep your photos and videos, well, your photos and videos, instead of selling it off to a major corporation. Now, this does sound like an ad at this point, but Immich does literally have everything that you want out of Google Photos, including a GPU accelerated image context indexing, so you can go back and look for people, places, or things, as well as text, as well as other features that make Google Photos great, like memories, the ability to create albums and put photos in, storing metadata that can be displayed if you click the info tab, or GPS enabled photo capture on your mobile phone or even your camera, as well as link-based photo in video sharing, so you can just send a link to someone via text or whatever, and let's say someone has an iPhone, an older one, that doesn't have RCS yet, you can send them the link to a high quality video and they can just watch it in high quality instead of it being compressed to like a 10 kilobyte video, which is something I'm sure we've all experienced before. So I got Immich set up in the apps tab in TrueNAS, and then I tested trying to upload the photos from my phone to the thing, and it all worked very well, and I would highly recommend Immich for anyone trying to take control of their own data. And so after all of that, I would say this project is a job well done. But there is one issue. And that issue is not something related to the computer itself, but more personal. It is a good chance in 6 months I will have transferred to an actual college, and I will not bringing a whole NAS server with me wherever I end up, and so I will have to leave it at home. You might be asking yourself, why not set it up so it can be managed remotely? Well, my parents' house is in an area that is highly susceptible to power failure, and even though they're close to town, the internet is rather lackluster. I am led to believe, after testing it via LAN at both my house and my boyfriend's house, which is nearby, that I think the upload is locked to 41 megabits per second, which is strange, but I don't know. All of this in addition to the fact that I have no knowledge on how to properly work cybersecurity, so I am in no position to make my storage accessible from outside this home network. So as much as I make a big stink about, owning your own data and not paying these companies to sell your information to whatever's going on out there, you do have to acknowledge the fact that you are paying for security, redundancy, 24/7 uptime, and data center grade transmission rates. Because of this, I believe that biting the bullet and paying for Google Photos to have access to all my photos and videos for the next however many years is worth the price, knowing that all my stuff will be there on the other side, allowing me to rest a lot easier knowing I'm not going to have to deal with some personal management of the system, or even worse, suffering potential data loss because of some minor mishaps. So what does that mean for the actual network attached storage that I just built? Well, I will use it for however much longer I'm here. It is 4 terabytes of network attached storage, which is quite immaculate, but I'll have to figure out something to do with it once its time is up. I'm not going to just get rid of it and not use it at all. So it is a nice backup, so I can kind of get stuff off my computer and keep that cleared out. And as of right now, I did back up my entire YouTube channel and every clip I've created for every video to it, which was about 0.5 terabyte off of the 2 terabyte external hard drive I kind of had it sitting on. So now it has some redundancy and will be kind of in there for the long term in case I need the footage for other stuff, and to kind of catalog this YouTube channel in case anything ever happens to it. I still have all my data backed up, which is great. All right, hello from my car. My room's pretty messy, or the place where I record, so I decided to come out here. Plus it's a hint at the next video that's coming out, so stay tuned. You might know what it is, but I digress. Anyways, so what did this all cost? Well, it costed about $329.62. Prices, I would say, have gone up by this point if you're trying to do something like this again, or trying to follow the exact steps I took. It's gonna cost more, especially because I did build this a few months ago, and even though since then RAM prices have gone down like by 1% because of the Google Turbo Quant stuff, it's gonna cost more. But how does that compare to the open market? Well, I would say there are cheaper options. If you want something that's gonna connect to the cloud and you can just use like a literal portable hard drive that you don't have to carry around with you, but you have accessible, there are options. Obviously, with the cheaper stuff, you're gonna get worse performance and lower capacity, and oftentimes you don't even really get to choose which hard drive you get. It kind of just comes with one. So what would I say a fair comparison to this be? Well, if you look at the market right now for something that might cost even more than what I built this for, well, you can see that the price I built this for is actually really good. For example, this NAS, wherever it is on the screen, costs around $500. You get significantly less RAM, significantly less compute. The form factor might be a little nicer, but oftentimes with this kind of priced network attached storage, and the pre-built ones in general, is that you don't get to choose the operating system. There are ones that do. You kind of have to seek them out a little bit, but the ones you can find pre-built often do kind of just have a system built into it, and you can't really tamper with it too much. So the fact that I built it for even less, get better performance, and I can choose my own operating system so I can do whatever I want with it, makes this actually a very good deal. So if you were someone who were looking to make a network attached storage, whether you were on the market to buy one or build one, I would have to recommend you build one. The DIY saves you a lot of money, and if you do your research, you will genuinely save a lot of money. Obviously, building anything that has to do with storage in 2026 isn't easy because of the aforementioned AI bubble. However, it is doable, and it will save you money than buying it pre-built. One more thing I would have to recommend, stuff like Facebook Marketplace. Though, do be cautious. Hard drive and storages can be susceptible to time a lot more than other computer components. So if you're looking for stuff on a marketplace like used on eBay or used on Facebook Marketplace, make sure you know what you are looking for, but I would recommend secondhand because in general that is really good to go off of, refurbished and secondhand. Pretty good deals as long as you don't get scammed and you actually know what you're looking for. With that being said, I would not take this video as a tutorial on how to build one-to-one because it was a lot of trial and error, especially with the motherboards and the CPUs, and kind of just, it was more just like trying to figure it out. It's the first network attached storage I've built. Honestly, it's kind of the first computer I've built because I've had to interact with the PCIe slots, but it is a good grounds for starting research. If you're trying to look in how to build one that it takes the form of a computer, I would recommend using this video to kind of get your senses on what you might need to get in order to get a working computer that can actually connect to the cloud and you can use to attach stuff. If you're willing to, put it online so that you can access it remotely even if you're not on the same network. So to finalize what I'm saying, I'm just do a DIY. So anyways, with my lack of room, let me finish this up with saying this has been Ben Gray Digital. Thank you for watching. Like this video. Comment if you have any suggestions on how I should do this better in the future. And I'll see you in the next one.